Welcome back to the deep dive.
Hey there.
So today we're going to dive into something, well, pretty fundamental that's been reshaping things in 2025, zero-knowledge coprocessors.
Ah, yes, the crypto GPUs, as some folks are calling them.
Exactly. And our mission today really is to understand how these things are tackling that classic blockchain trilemma.
Right, because the core idea is they take the really heavy computational work off the main blockchain.
Oh, okay.
But crucially, they don't just send back the result. They send back a proof,
Yeah.
a tiny cryptographic proof that the computation was done correctly.
So the main chain doesn't need to redo all the work. It just checks this little receipt.
Pretty much like a 200-byte receipt for potentially massive computations.
Yeah.
That's the magic for layer 2 scaling, getting that throughput and privacy, but still inheriting layer 1 security.
Right, that succinctness is key. Okay, so let's start with the networks actually using this tech day to day, the ZK rollups.
Yeah, the scalers?
And the name that keeps coming up is Scroll. Seems like the leader among the zkEVMs, right? Those Ethereum-compatible L2s.
Definitely leading the pack by mid-2025. Their total value locked TVL was huge, around $748 million.
And they hit that L2 beat stage 1 security status, too. Why is that such a big deal for you listening?
Well, stage 1 means they're starting to take off the training wheels. The system can upgrade itself without needing a centralized group signing off every time. It's a major step towards, well, real decentralization.
Okay, big step. But the sources we looked at highlight a risk. The sequencer, the thing ordering transactions, and the prover, the part doing the ZK magic, they're still centralized for now.
That's the near-term risk, yeah. Full decentralization hinges on their SCR staking rollout, so it's still kind of centralized until that's fully live and distributed.
A trade-off for performance now, I guess.
Seems like it. Now, contrast that with Polygon zkEVM. Technically, it was really impressive.
Yeah, the numbers looked great, like 1,000 transactions per second capacity and fees around, what, $0.002?
Almost nothing. Super efficient. But then, mid-2025 came that big announcement.
The pivot. Polygon said they're sunsetting the zkEVM chain by 2026.
Yeah, big shock. And you saw the TVL just plummet from a peak over $300 million down to like less than $500,000 by August.
So why walk away from something that seemed technically sound?
Strategy. They decided to pour everything into their ag layer framework. The idea there is unifying liquidity across all their different chains.
So sacrificing one successful piece for the bigger picture, the interconnected ecosystem.
Exactly. It's about making everything work together seamlessly. A tough call, but shows how much they value that unified approach.
Yeah.
It's a real-world example of strategic sacrifice.
It definitely shows the challenges. Okay, so that's the roll-ups using the proofs. But who's actually generating these proofs? The heavy lifting part.
Right. That brings us to the ZK proving networks. Think of them as like compute as a service for ZK proofs. Shared infrastructure.
General-purpose zkVMs that any blockchain can tap into.
Precisely. And a major one here is RISC Zero. People call it the ZK CPU.
Because it uses the standard RISC-V instruction set, making it really general purpose.
That's the idea. Not tied to one specific blockchain environment. And their boundless mainnet beta launched July 2025. Explosive growth.
Yeah, I saw the numbers. Over 399,000 proof orders processed in just a few weeks.
Insane demand. And here's where it gets interesting and maybe a bit tense. Big players, like Bitmain, are jumping in.
With specialized hardware, ZK ASICs.
Exactly. Purpose-built chips just for generating ZK proofs, faster and cheaper. It's the industrialization of ZK proving.
Which boosts efficiency, great. But doesn't that raise the centralization question again? If only big players with specialized ASICs can effectively participate.
That's the core tension. Performance versus the decentralized ethos. If large mining pools dominate the proving network, does it undermine the whole point? It's something the community is really watching.
A critical trade-off to track. Okay, then there's Succinct, more of an integrator.
Yeah, that seems to be their angle. They launched their ProveEV token and prover network in August 25. But even before that, they'd processed like 5 million proofs for clients in testing.
And they're focused on partnerships, right? Getting this tech plugged into existing chains.
For sure. They've got OP Succinct running with Optimism and the Tandem project ongoing with Arbitrum. They're building the plumbing, the connections.
Makes sense. But the potential risk mentioned is adoption friction because of their ProveEV token. Why is requiring payment in their own token a hurdle?
Well, it just adds a layer of complexity for projects, doesn't it? If you're, say, Arbitrum, you now need to acquire and manage ProveEV tokens just to pay for proving.
Instead of just paying in ETH or stablecoins.
Right. It adds overhead, market exposure. It might make some potential clients hesitate, maybe look at competitors with simpler payment models.
Got it. So wrapping this up, what's the big picture takeaway for you listening?
I mean, the ZK coprocessor boom isn't just hype anymore. We're seeing real utility, faster rollups, near-instant finality, trustless bridges between chains.
Yeah.
It's delivering actual, 10x improvements in what blockchains can do.
Verifiable computation is becoming a real usable commodity.
Exactly, like cloud compute, but for trustless computation.
Yeah.
ZK tech is moving way beyond just scaling block space. It's changing the architecture.
Which leads us to that final provocative thought. If networks like RISC Zero and Succinct really succeed in making verifiable computation a cheap, accessible commodity,
Allowing dApps to essentially achieve, infinite TPS for complex work done off-chain but still verified.
does that fundamentally change what we even need from a traditional layer 1 blockchain? Does its role get completely redefined?
That's the big question, isn't it? Something to definitely mull over as this tech continues to mature.